Are you tired of constantly looking up shell commands on Google or LLMs, even though you used the same command just a few days ago? If you, like many other developers, use multiple OS, then it's even more difficult to remember commands. Well, what if I told you could forget all your shell commands by using just a few lines of Python code? In this video, I'll show you how to create a terminal-based AI tool using Langchain and OpenAI that will generate shell commands right from the terminal itself for you. Whether you are Mac, Windows, or any other distribution of Linux, this tool will have you covered. So just as an FYI, this is nothing complex and we can do the entire thing on the ChatGPT UI itself. But the convenience and efficiency which we get by searching for commands directly from the shell itself, well, that has personally been saving a lot of time for me since the past few weeks I've been using this. So let's talk about the components we'll be using for this tool. So number one is Langchain. So Langchain is a Python-based framework which lets us interact with LLMs in very few lines of code. The second is OpenAI library. Our entire tool will be powered by GPT-4. We can use GPT 3.5 also, but GPT-4 is much more accurate and it provides a lot of reliable results. So we'll be making our tool cross-platform so that it runs on Windows, on Mac, it runs on PowerShell or CMD or ZSH or Bash. So now we'll go to the code and start building it. We will install the dependencies. We just have two dependencies, Langchain and OpenAI. I'm doing it in a virtual environment. You can do it on a normal Python or you can create a virtual environment. We'll create a new file, shellgpt.py, which will contain all the logic. Then we'll create an LLM object. It's nothing but a way to talk to LLMs. In this case, OpenAI's GPT 3.5 using Langchain. Then we'll set our environment variable with the API keys so that we can interact with the GPT 3.5. So creating an API key is easy. I'll just go to Google and search OpenAI API key. I go to the platform.openai.com link. I'm already logged in. If you're not logged in, you can log in with your Gmail account or any other email. I'll create a new secret key, demo, YouTube. And this is the value. I'll just replace this in my environment variable. So this is the prompt. This is where we tell LLM how to behave. So we are asking it to basically come up with a series of bash commands which will perform a task. We are also asking to reason step by step. This is for our own observation, and we are giving it the format. The format is question. We are giving a sample question. And then this on line number 12 to 15, what we can see is this is a reasoning. We are telling LLM that, hey, why don't you reason like this? You need to break it down. So we can see it's breaking down, list all files in the directory, create a new directory, copy the files on the first directory into the second directory. And then we are telling it that it needs to give the actual bash commands in something prefixed with something called command and triple backslash or backtick. So we can see line number 17 to 19 are the actual commands. So this is a sample format which we tell the LLM to follow. And then from line number 24, this is where we actually ask the question. Now we'll create the prompt template. Prompt template is nothing but a way to inject values in our prompt in real time. So in this case, we'll be injecting the value of question whenever a user asks a question. It's something which Langchain provides and it just makes things convenient to manage. Now we'll create a LLM chain. LLM chain is just an execution unit. It lets us talk to the LLM by passing the prompt. Now we'll be taking the input from the user in form of a command line argument. Just to be on the safe side, we'll add a if else check that in case a user has missed passing an argument, we'll throw an error. So now what we'll be doing is we are just running the LLM chain. We are passing the value of the question and we are telling it to substitute it in the prompt template we just created above. So before running, let me replace the value of the API key with the actual value. I'll let me wrap this line number 6 and 7 in a custom function, and then I'll fold the method so that nobody can see the actual API key. I'll replace the values And as an FYI, I'll also replace the model to GPT-4 instead of GPT 3.5 Turbo. You can use either, but GPT-4 is more accurate. Now we'll invoke it and ask it to create a file nums.txt and add 1 to 100 in it. So we can see it has given its reasoning first. We don't really need to know about it. And what we actually care about is what is inside these triple backticks followed by command. So we can see the two commands touch nums.txt as well as a for loop. And if we execute it, a file is created with the correct values. So instead of actually executing the Python file always, what we'll do is, just for our convenience, we'll create an alias in our bash or zsh or whatever shell we're using, its profile. And an alias is just a shortcut way to trigger a particular command directly from the terminal. So here I'm just appending SGPT alias, and in the alias we can see what I am doing is I'm sourcing basically I'm activating my virtual environment first, and then I'm triggering the script. If you're not using a virtual environment, you can skip the first one. You can directly add the Python command. So once we've added that, we'll just quickly source it so that our changes reflect in this session of terminal. And now we can see that we are able to trigger this Python file with just using SGPT alias. I asked it to create a standard git ignore file for Java based projects, and I think it has done a decent job. Now let me ask it another query. I'll ask it to create a backup of my directory and upload it to Google Drive. I can see the response and it gives me a bunch of commands to do for installing the zip and Google Drive initialization, etc. Let me try to copy the first command and run it. Wait a second. Now apt is a package manager for Ubuntu and I am using Mac. We have a problem. We have hard-coded in a prompt and asked our LLM to generate bash specific commands. But what if a user is using Ubuntu or Windows or any other flavor of Linux? Well, to solve that, we need to pass some dynamic information to the prompt in runtime. So there are two things which vary. One, the OS in which the program is running, and second, the shell. So we'll use some Python mechanisms to detect the OS as well as the shell during runtime, and we'll pass it to the prompt and explicitly ask the LLM to return commands for those particular shell and OS combination. So as we can see, we are hard coding the bash in line number 20 in the prompt itself. So just as a proof of concept, what I'll do is I'll hard code in my prompt that I'm using a macOS, Apple OS. So this line tells LLM to give commands specific to macOS. We'll run the command again. So here are the results. We can see now that instead of using apt-get, we are using brew install drive, and brew is the package manager for our Mac OS. So this seems to be the correct set of commands. So now we'll replace the bash with shell, a generic shell in my prompt. And instead of Mac OS, what I'm doing is I am injecting the OS name and shell name in the prompt. I'm telling the LLM to ensure that the commands are for those specific combinations. To get the actual shell, we're using the OS module of Python. It checks whether the OS is NT, which is Windows, or is it Linux, and accordingly it tries to get the environment variables which contain the name of the actual shell. We are defaulting to bash in line number 25. Similarly, we'll also get the OS name. We are using the platform module by Python, and we can see that if the OS name is Windows or Darwin, then we know it's Windows or Mac OS. If the OS name is Linux, we are using a third-party library called distro, and what it does is it basically tells the actual distribution name. So instead of just Linux, it will tell me it's a Debian or Red Hat or whatever. So this is how we install the package, pip install distro. Now we'll invoke those two methods, get the shell name and OS name, and we'll update a prompt template to get those two variables as an input. And while executing the LLM chain, we'll pass these variables. I'll just reformat it a bit. Now also what I'll be doing is I'll be actually printing the template with the injected variables just to see if we are doing things correct. I'll comment the actual execution and we'll run this command. Yep, so we can see that this is a prompt, and ensure the commands are for the OS, Apple, macOS, and the shell ZSH, which is correct. So it's correctly substituting the values of the shell as well as the OS. I have also tested this for Windows PowerShell and it works for there also. In case of PowerShell, sometimes it defaults to CMD. So it depends on your Windows configuration. So the easiest way is just hard code your shell value. Well, that is good. You know what would actually be better? If we could have a back and forth conversation with the LLM right from the terminal itself. I do not want to mention everything I want to do in the same prompt. What I want is to break things down, have the ability to execute the first command, then a follow-up second, then a follow-up third, and a follow-up fourth. Luckily for us, Langchain provides us a very convenient abstraction called memory. So what is memory? Memory basically adds the entire chat history in each request and sends it to LLM. So if I ask a question, the LLM will send me a response. If I ask a follow-up question, what Langchain will do, it will basically add the previous question and the previous answer to this prompt itself and then send it to LLM. So LLM will now have the context and will be able to accordingly answer my follow-up question. We'll add memory, something called conversation buffer memory. We don't need to know it, what it means, but it's just a way to let us pass the entire chat history to GPT. We'll pass the memory in the LLM chain. We'll also need to modify a prompt template and pass the key, memory key, chat history. So this key is basically the variable which contains the entire chat history. And if you see, we are basically injecting the chat history variable in a prompt. The reason for doing it is that once we give the initial structure of the prompt, at the end, we are also, before asking the question, we are also pasting the entire conversation. So our LLM will know what has happened till now and what is the latest question. Now also, what we need to do is we need to have a continuous session so that our memory or our process, basically our program, is not terminated. So we'll create a infinite loop and we'll keep on asking the user for the input question, and we'll keep on passing that along with the chat history to the LLM for the response. And the user can ask n number of questions and the program won't be terminated unless the user actually terminates it. So instead of taking input from as a command line argument, we'll be taking it as a Python input. So I'll ask you to create a directory named new dir, and the command seems to be correct. Now we'll ask a follow-up question to create 10 files named in the new directory without actually passing the name. And we can see the command is cd new underscore dir and touch. So it seems that the LLM knows the context and it's able to accurately give the commands. We'll again ask a follow-up question and ask LLM to append the word Langchain in each file without actually mentioning the names of the files. Yep, we have a for loop and which actually iterates through the file names and concatenates Langchain to each file. So that was that. Now we can do a ton of other things. I played around with the actual execution of the code instead of just displaying. So Langchain provides something called bash LLM chain. So what it does is it actually generates the command for you and actually executes it. I I'm personally not a big favor of it because I find it to be a bit risky. I like to be in control. So I'm actually just limiting the tool to just print the commands instead of executing it. Additionally, we can also have a general GPT search from the terminal itself. All we have to do is have an if else and let a user add a flag while invoking the function. If a user asks for a general query, we can have a prompt which just asks the LLM to answer the question as correctly as possible. And if we have a shell based flag, then we'll use a prompt we just created. So we can see we can do a lot of other things with this tool. Although this tool is simple currently, it actually is very convenient and it saves me a lot of time, and I'm sure it will save you also a lot of time. The code for this is hosted on my GitHub account and the link for that is in the description box. Thank you.